in chemistry under the topic mole concept. We are still handling this big topic, mole concept, and today particularly we are going to look at how to determine masses from equations. We are going to look at masses from equations. That is going to be our major point of emphasis today as we continue with this topic. Before we go far, I need to remind you about a few things that you need to do. Please make sure you log in to our website account. Create an account there. After creating an account, you log in and be able to receive all this work plus other topics that we have been covering. Okay? Then make sure you have a book with you. Make sure you have a pen. Make sure you have a pencil and a calculator. A calculator should be a functioning calculator. Okay? Remember I told you to use your free time to practice how to use a calculator. So today we are going to calculate very many things here. Okay? Make sure you invite someone who is not near the TV and is supposed to be learning with you. Invite a friend, invite a sister, invite a brother, invite neighbors, okay? If you have a TV and neighbors don't have, please invite them and they learn from your place, okay? But should be within the proximity, okay? Today, we are going to start with what we looked at yesterday, and we see how it will help us to understand today's work. Yesterday, if you can look at our slides, yesterday we looked at how to calculate empirical formula. Okay, calculating empirical formula, calculating molecular formula, and we had a number of steps that we discussed. We said that for you to be able to calculate an empirical formula of any compound, you have to make sure you first draw your plan. Which steps are you going to follow? The steps are there. You write down the symbols of all the elements present in a compound. We did that one. If you are not present yesterday, please, you can go and watch the videos. Okay? The video is there. You'll be able to access this work. Then the second step, we said you write down the mass or percentage composition by mass below each element. After writing the symbols of the elements, then you write their percentages. After that, you find the number of moles or relative number of atoms of each element by dividing the mass or percentage composition by relative atomic mass. Okay? That's what we said. When you do that, you get the number of moles. And we said that once you have the number of moles, then you can use those moles to determine the mole ratio. How do you get the mole ratio? Is you look at which one is the lowest number, which one is the smallest number. After looking at which one is the smallest number, then you divide that smallest number throughout. Okay? Then what you get is what they call mole ratio, and you use the mole ratio to get the empirical formula. We say that once you have the empirical formula here, you have the empirical formula. Then if you multiply it by a given factor n, you'll be able to get the molecular formula. Okay? Once you have the empirical formula, you'll be able to get the molecular formula. That one we discussed it yesterday. At least this one should keep in your head. And we said that once you get a wrong empirical formula, you'll not be able to get the correct molecular formula. So you should be so keen enough to be able to get the correct empirical formula so that you can also get the marks for, or the marks for molecular formula. And we said molecular formula, in most cases they give you the molecular mass, or they give you the density. If they give you the density, you multiply times 2. If they give you the molecular mass, you consider that. Then when you go to our next slide, we look at what we have been emphasizing always, that we have said that we are dealing with a topic that is called mole concept, and we said we shall not tire from reminding you that mole concept deals with determining or counting the number of particles. Okay? Okay, you turn to your neighbor and tell the neighbor that we are dealing with the mole concept, and mole concept is aiming at determining or counting the number of particles. We also say that a mole is very important in this topic, and we say that a mole is the amount of substance containing 6.02 times 10 power 23 particles. The reason why I keep bringing these things is to make sure that at least let them be, you keep looking at them and make them be part of you, okay? And once they are part of you, you'll be able to do these numbers. We also say that 1 mole, looked at a concept saying that 1 mole, okay, 1 mole is equivalent to, 1 mole is equivalent to the relative atomic mass of a given atom, okay? That means this one is of an atom, or it can be equal to the relative formula mass of a compound. Can be either 1 mole equaling to 1 to the relative atomic mass of an atom. If we don't look at the relative atomic mass of an atom, we can look at the relative formula mass or relative molecular mass of a compound. That means if it is not an atom, we are going to be dealing with a compound, okay? So this one is going to be so important in today's lesson, okay? Knowing that 1 mole is equal to the relative atomic mass of that atom, or equal to the relative formula mass of a compound. You see, in chemistry, a few things you need to put in your head to be able to calculate all the numbers, okay? Just once you have a few concepts, the major concepts, then numbers will be easy because they keep just alternating the figures. Okay? So when we go to our next slide, we look at the objectives of today's lesson. Okay? We look at the objectives of today's lesson. And we say the objectives of today's lesson, we are aiming at achieving 1 major objective, okay? There are so many things you're going to achieve today, but at least make sure you achieve this 1 major objective, which is determining the mass of a substance or a compound from an equation. Once you are given an equation, are you able to determine the mass of any substance, any compound they ask for in that equation? You can be able to use the equation to determine its mass, okay? That means that one will lead us to the next slide, where we shall talk about a number of things. Calculation of masses from equations. Have a look at that slide, okay? We have said that, we have always said that moles and mole ratios can be used to calculate the amount of substances reacting and products being formed. So by the knowledge of this 1 mole equaling to that one, we can be able to determine the amount of substances reacting or the products being formed. Let us first remove this and we look at that one. Everyone has taken note of the topic. So what we need to keep here is 1 mole being equivalent to the relative atomic mass of an atom, okay? or relative formula mass of a compound. This one we are going to be applying it in today's work, and we need to keep it there. 1 mole is equivalent to the relative atomic mass of an atom or relative formula mass of a compound. So on our slide we are saying that moles and mole ratios can be used to calculate the amount of substances reacting and products being formed. Take an example. If A is reacting with B to produce C plus D. Okay? If A is reacting with B to give us C plus D. That means A and B, these are the substances reacting. A is reacting with B to give the products, and the products you have C and D. So when we talk about moles, anything written before this compound or substance here, okay? If we put here A, we put here small b, we put here small c, we put here small d. So we shall say A, B, C, D. This one stands for amount of moles. Amount of moles, okay? If we say that here we have A moles of A atom, okay? So any figure that will be written there, it will be standing for number of moles, okay? If you don't say amount, you can just put here what is common to you. Number of moles, okay? A, B, C, D, these small letters will be standing for number of moles. And that's what we shall be using to calculate the masses, okay? Also, we are saying that this requires the equation to be correctly balanced, okay? It requires you to write a correctly balanced equation. You need to write an equation and you balance it for you to be able to calculate for masses. Then we are saying that such an equation that is correctly balanced, we may call it as a stoichiometric equation. Okay? The stoichiometric equation is the one that it is an equation that is correctly balanced. Okay? Then what is stoichiometry? Stoichiometry is the relationship between amounts of reactants and products in a compound. It's just the relationship between the amounts of reactants and products in a compound. And we have said that the word stoichiometry equation is an equation in which the reactants and products are correctly balanced. Okay? I'd request for slide 9. So that people can look at the steps that we are going to follow while calculating for calculating for masses in today's lesson. Remember, we are looking at determining or counting the number of particles. Let us look at slide 9 and we see what is there. We are saying that stoichiometric equation is an equation in which the reactants and products are correctly balanced. And now we want to look at the steps that are followed in this calculation. Okay? When we are calculating for these masses, what are the few steps that you can follow? We are saying that for you to be able to calculate for masses, you need to write down a balanced equation for the reaction. You look at the reaction that is taking place. If they are saying that chlorine is reacting with ethane to give tetrachloromethane or chloroform, okay? You need to see what are the reactants and what are the products, then you'll be able to write them, and you balance the equation. After balancing the equation, you need to write down the moles of substances that concerns the question. Okay? After balancing, I've said that A, B, C, D, they will be standing for number of moles. Okay? So once you identify what is standing for AB or what is standing for A, you identify it. If it is 2, you say they are 2. That means that 2 is standing for number of moles. That means they are 2 moles. Then you convert the moles into grams. How do you convert moles into grams? You use this one. 1 mole is equal to the relative atomic mass of an atom or relative formula mass of a compound. Okay? So let us move to our next slide and see our very first example. Let us see our very first example, and we see how we can apply this concept. You know, we are in chemistry, especially this topic, we don't need to talk a lot, you just need to calculate the things and they come out. Okay? We are going to work together, and where we have reached that in the middle of the topic, at least everyone has a concept. Okay? So you can contribute very well. Calculate the mass of iron 2 sulfide formed by heating 64 grams of sulfur with excess iron fillings. Okay? You calculate the mass of iron 3 sulfide. Okay? Calculate the mass of iron 2 sulfide. Number 1, it is talking about iron 2 sulfide. That is the mass they need. Okay? They are saying that is formed by heating 64 grams of sulfur. You heat. Okay? You heat 64 grams of sulfur. Okay? But when this sulfur is reacting with iron fillings. Okay, so that is the question. And now once we write down this one will help us to write our equation. Remember, they are saying that iron 2 sulfide formed by heating. That means formed by heating. When they say formed, meaning that this one is the product, because they are saying it is formed. Then by heating, that means the ones they are heating, they are the ones which are the reactants. That means the reactants we have sulfur, which is S, and it is a solid. You add there iron, which is a solid. You get iron 2 sulfide. Okay? Iron 2 sulfide. First look at the equation. Is it correct on your side? Okay? You have to begin with the equation. Once you have this equation, remember sulfur, they have said sulfur is valence 2. And they are saying in brackets here that there is iron 2. That means iron 2, the valence is 2. That means it will be 2, 2. When the valences are the same, they cancel and write element symbols close to one another. Of which that's what we have done. So can we balance this equation? We are saying that sulfur. How many sulfur atoms do we have here? We have, everyone can see it. How many are they? It is 1. Don't need to write here 1 to indicate that this is 1. This is 1 atom of sulfur. What do we have on the product side? We have 1. Iron. We have 1. That's it, you have 1. And to balance an equation means that what you have on the reactant side should be equal to what you have on the product. You can't form what you don't have. Okay? Or you can't form less, yet you had a lot. You can't boil 2 eggs and then after you are having 1 egg as the product, boiled egg. Fresh eggs, you were having 2. But after boiling, you have 1. It is impossible. Or after boiling, you have 6. It is practically impossible to boil 2 eggs and at the end you come up with 6 eggs. So what you boil is what you get at the end. So that is the same here. What reacts here is what you form. The amount that you put in is the same amount that you produce, but in a different form. Okay? So that equation is balanced. So once we have the balanced equation, we said we rate now the moles. What do we say? They are talking about iron 2 sulfide being formed by heating 64 grams of sulfur. That means they are not concerned with iron fillings. Okay? They are concerned with sulfur. So they are saying how many grams can be formed by this one. If you are saying that 1 egg plus water, you are forming 1 egg with water. That means now they are asking you, what if you boil 10 eggs? What are you going to form at the end? Okay? So that's what we want to look at. But now here, they are giving you that 1 egg, they are not giving it to you in that amount. They are saying 5 grams. Okay? 64 grams of eggs. Okay? What can they form? That means you go back and look at, okay, 61, what about 1 egg? 1 egg is having how many grams? Then after getting the grams, then you look at, okay, those grams will be representing how many eggs. Then that means you go back and calculate. You know, we normally use those examples which are easy to get this. So here we are saying that sulfur. If they are saying sulfur, that means you say, what is us? They are asking you for iron 2 sulfate. What we said, what they want goes on the right-hand side. What you have goes on the left-hand side. So you say, I have what? 1 mole of sulfur. Can't we see it? It is 1 mole. That means 1 mole of sulfur formed. Okay? 1 mole of sulfur formed. If it is not passed, you can put it like this and say forms. Okay? 1 mole of sulfur, when you boil it, when you burn it, when you heat it, it forms 1 mole of iron 2 sulfide. 1 mole of iron 2 sulfate. 1 mole is forming 1 mole of iron 2 sulfate. Now, what do we want? We want grams. So we change this 1 mole into grams. Remember, we said 1 mole of an atom is equal to the relative atomic mass. So we check in our brackets. We will find there in brackets, they have given you here in brackets that iron equals 56, okay? And the sulfur equals 32. They have given it to you in brackets. So that's what you use. You come here and say 1 mole of sulfur is standing for the relative atomic mass. That means you leave alone the mole and you go with the relative atomic mass. You say it is 56, sulfur is 32 grams of sulfur. 32 grams of sulfur, you say they form how many? Now 1 mole of iron 2 sulfate becomes iron is 56. It is 1 atom plus sulfur is 32. That means these are grams of iron 2 sulfide. Do you get me here? Remember I said the other time that we are beginning with simple concepts. At first we began with calculating for molar mass. We went to relative molar mass, went to relative molecular mass. We went to calculating grams from moles, went to comparing moles with grams. Now we are here. So here we are going to move fast since we know all these things. Okay? We said 1 mole, which is here. It is representing the relative atomic mass, and we have put it here. 1 mole is representing the relative formula mass of a compound. We are putting it there. So we go ahead, we say 32 grams of sulfur forms 56 plus 32, okay, that is 88 grams of iron 2 sulfide. Okay, that is it. We say that once we have here 32, we have to make sure that we take whatever is on our left hand side to make sure we have one. If they are saying that 32 eggs, okay, if they say that 32 grams of rice, if you heat them, okay, they will form 88 grams of food, prepared rice. Okay, that means with birungo. Okay, some spices are there, but grams will increase. And you know that when you put rice in the saucepan, it looks like a little bit little, but when after preparing it, it increases in volume. So here we are saying that if 32 can give 88 grams, what about one? If you buy one, if you hit 1 gram of sulfur, that means they will form 88. What is formed by 32 divided by 32 grams of iron 2 sulfide. We go now to our question. It is 64 grams of sulfur. 64 grams of sulfur forms 88 out of 32 times 64. What is formed by 1 times the 64? We get iron 2 sulfide. Okay? Iron 2 sulfide. Here we put in our calculator. 88 divided by 32 times 64. What do we get? What do we get? Get 176 grams of iron 2 sulfide. We get 176 grams of iron 2 sulfide. That is going to be our answer. And so these are the steps. In most cases, I take much time explaining the first example, okay? To make sure that at least you understand from the start. It is not, I'm not trying to waste time, but we are trying to make sure that you understand from the start, from the word go, okay? So that other examples will just be a walkover. So that was our first example. Hopefully that we have been moving together and you have followed everything. So let us go to our second example. On the next slide, what is the mass of magnesium required to form 55 grams of magnesium oxide? Okay? We are looking at the mass of magnesium required to form, that word for is form, to form 55 grams of magnesium oxide. Okay? So you can take off this one and we look at that. This one was amount of iron 2 sulfide required to form when you hit 64 grams. Now, this one was requiring you to find a product when you are given a reactant. But here you have been given the product and they want you to calculate for the reactant, okay? They are saying that what is the mass of magnesium required to form 55 grams of magnesium oxide, okay? They want the mass of magnesium required to form 55 grams of magnesium form 55 grams of magnesium oxide. So we want to see the mass. Now we are beginning with the reactant side. We want to find the atom on the reactant side, the substance on the reactant side, the grams of the substance on the reactant side. Can call it what you want, okay? So that's what we want as of now. Remember the previous example, we are calculating for number of the masses of a product. Now we are looking for the mass of a reactant. And we said the first thing you do is to write the equation. When they say magnesium, to form magnesium oxide, what goes into your head? That means what is required to form magnesium oxide? What do you want? You need to be with magnesium and oxygen. So here they have not put for you oxygen, but you need to know it that to get magnesium oxide, you have to react magnesium, okay? You react magnesium solid with oxygen gas to get what they call magnesium oxide solid. Now we are going to see, is this equation balanced? One magnesium atom. We have no problem with that. This one stands for, represents the atoms of oxygen. That means here we have 2 oxygen atoms. And the other side we have 1. What do? We put a 2 here. Okay? We put a 2 there. And we say 2 oxygen atoms, 2 oxygen atoms, 2 magnesium atoms. How many magnesium atoms are here? We have just 1. What do? We put a 2 there. And our equation will be balanced. And we shall call this one a stoichiometric equation. Okay? An equation that is having reactants and products well balanced. Are we together? We are saying this one is the stoichiometric equation. I need to write that word, I think. You don't write this word before you balance the equation, because for it stands for a balanced equation. Okay? When you write an equation and it is not balanced, don't call it a stoichiometric equation. Okay? So once you have this one, we said the next step we go. Number 1, write an equation. Number 2, put the number of moles. Number 3, convert moles into masses. Here we say, remember they said, what is the mass, the amount of magnesium required to form 55 grams of magnesium oxide? What are you forming? You're forming magnesium oxide. That means you have red magnesium oxide, but you want magnesium. And remember we said, what you want goes on the right-hand side, and what you have goes on your left-hand side. It is not what you don't want. What you have goes on the left-hand side. What you don't have, what you want to find, goes on the right-hand side. So let us begin with what we have. We have 2 moles of magnesium oxide. Are they 2 moles? Am I correct? Yes. 2 moles of magnesium oxide, we say that are formed. Because this one is the product. They are formed by how many? Magnesium, by 2 moles of magnesium. Okay? 2 moles are formed by 2 moles of magnesium, and that's where we are. Okay? Once you have that one, that means now we're going to convert moles into grams. And now we say these are 2, okay? 2 moles. That means just a mole is represented by relative formula mass of a compound magnesium. We go back and check in our brackets. In those brackets, you find there that magnesium is equal to 24, okay? And you find their oxygen equaling to 16. I said this one, if you don't find it in brackets, you'll find it in at the end of the paper in the periodic table. You pick it from there. So we shall come here and say magnesium oxide is 24. It is one atom plus 16. Okay? These are going to be grams of magnesium oxide are formed by two moles of magnesium. Magnesium is an atom. That means we consider the relative atomic mass. That means it is 2 times 2 in brackets 24 grams of magnesium. Are we together there? Okay? Hopefully that you can read all what is written on the blackboard. And as well you are following. This is example 2. We have already done the first example. That means things are easy now. They are easy on your side. If you get 24 plus 16, you get 40. 40 times 2, that is 80. That means there are 80 grams of magnesium oxide. They are formed. They are formed by 24 times 2, that is 48 grams of magnesium. Okay? 48 grams of magnesium. We say that once you have this and that means what we go to is if 80 grams are formed by 80 grams are formed by 48 grams of magnesium. What about 1 gram can be formed by what? 1 gram, okay? 1 gram of magnesium oxide are formed by, you get 48 out of 80. And you say these are going to be grams of magnesium. 1 gram of magnesium oxide can be formed by 48. Now let us look at what we have been given. They have said what can be formed by 55. Once you know that 1 gram is formed by 48 out of 80, that means you'll be able to know what is formed by, what is formed from this, okay? What can lead to the formation of 55? If 1 is being formed from 48 out of 80, what about 55? That means 55 grams of magnesium oxide are formed by 48 out of 80. What is forming 1? Okay, then you multiply 55. You get the grams of magnesium. Okay, here, put it into your calculators and you tell me the right answer you are getting, or you write down the right answer. Okay? When you get 48, you divide it by 80, you will be able to, you multiply by 55, 48, divide by 80, multiply by 55. Please, I told you that during your free time, make sure that you play around with your calculators to discover where buttons are, and when it comes to the time for calculating numbers, it becomes easy for you. So here you'll be able to get 33 grams of magnesium. Hopefully we are there. 33 grams of magnesium. And these are the similar steps that you have to always look at. What is important is writing the equation. That one is very important. Secondly, you have to write the moles. See, identify the moles. If this one is the one which has been given, you put it on your left-hand side. What they are asking for, you put it on the right-hand side. The grammar, it doesn't matter. Okay? Doesn't matter, so long as you indicate that this one is being formed from the other one. Okay? What is important is involving putting all the steps there and getting the right answer. Please, if you get the right answer and when you don't have these steps and you just say that, I think I need to get the grams here. I divide them by the grams there. I multiply by these grams and I get this answer. These steps, if you leave them in the head, please endeavor to submit your head, or else you will not get any mark. Okay? So, to be safe, you put all the steps on the paper. Let's go to our next example. Let us look at the next example, which is example 3. Example 3 is saying, calculate the mass of copper formed when 3.2 grams of copper 2 oxide is completely reacted to the metal by hydrogen gas. Okay? Is completely reacted to the metal by hydrogen gas. The first question is saying you calculate for copper. Okay? The second question is saying how many grams of water was produced. Okay? The third one is saying calculate the mass of hydrogen used in the experiment. Okay? Those are the 3 things you have to look at very fast. Okay? But we are going to summarize them. Don't worry. When you see such a question, please jubilate. You can stand and smile and again sit down till you are right. Okay? But don't disorganize the room. Please, you can stand, smile, you again sit down. When they ask you what is the problem, I've seen an easy number here. Or you can tell them all the numbers I'm seeing there easy. I don't know why. Okay? Please, I continue to encourage you to stay home and stay safe. Okay? Stay home since you are able to study from home. Okay? Pastor Eve Senyonga and Pastor Jackson Senyonga, they have tried to make sure you study from home. So we need to appreciate them. Remember, the Pastor Jackson Senyonga is a man of God. Pastor Eve Senyonga is a woman of God. So they are serving the Lord. So may the Lord bless them. Okay? So on our question, we are seeing that we have 3.2 grams of copper oxide. They want copper, okay, being formed by, when you write 3.2 grams of copper 2 oxide, grams of copper 2 oxide. Okay? So, questions are requiring you to determine a number of things there. But if you analyze that question very well, if you look at the question very well, and you study it, it is showing you that they are reducing copper to copper oxide to copper. So they are telling you that copper is formed when 3.2 grams of copper 2 oxide is completely reduced to the metal by hydrogen gas. That means copper 2 oxide equation, copper 2 oxide, okay? Copper 2 oxide is a solid, okay? It is reacting with hydrogen gas. Okay? I want us to look at the very first steps, then the rest of the things you can do them. Copper 2 oxide. They are saying that it is being reduced by hydrogen gas. That is the hydrogen gas. When you react copper 2 oxide with hydrogen gas, what you form is copper solid plus water. Okay? Water is a liquid. Okay? You get copper solid plus water, which is a liquid. Once you have this one, then you are starting to smell the answer. Let us balance this equation. We say copper, we have one atom here. Is it one? Look at it. It is one atom. On the product side, we have one atom. Oxygen, we have one atom here. On the product side, we have one atom. Wow. Hydrogen, we have 2 atoms of hydrogen. On the product side, we have 2 atoms of hydrogen. So in terms of balancing this one, now this one qualifies to be the stoichiometric equation. Okay? Remember, stoichiometric equation is an equation that is well balanced, having products and reactants very well balanced. All right? So this one is our equation. Once we have this one, now we are going to see other things becoming easy. Remember, part A is requiring us to calculate for copper. Part B is requiring us to calculate for grams of water. Part C is requiring us to calculate for hydrogen. So it is very simple. You just alternate the grammar and you get the right answer here. The first part A, which is copper, you just say, if they have said there are 3.2 grams of copper to oxide, that means this one has been given, copper to oxide. Then you say 1 mole of copper to oxide, okay, forms how many moles? 1 mole of copper. Okay? Then you change. Copper to oxide is what? Remember we said it, if it is in moles, you put it in 2 grams. Copper to oxide is, you go back onto your brackets and you see copper is what? If you don't find it in brackets, you go and look into the periodic table. You will find out that copper, you find it as 64, oxygen 16, okay, hydrogen 1, okay? Are there the atoms present? Yes. So here you come and say this one is 64 plus 16 grams of copper oxide forms the 1 mole of copper is what? 64 grams of copper. Are we following? Then 64 plus 16, you get 80. Okay, 80 grams of copper, you say, forms the 64 grams of copper. We don't need to now continue. Once we have this one and we have that one, then we go to 1 gram, then we go to 3.2 grams. Okay? We get the right answer. I said in this last example, we are going to see the basics only. The steps, then the rest, because this one is going to be the same. We just start from there and get the right answer. Okay? Part B, they are saying how many grams of water was produced. Okay? How many grams of water? The same equation, you write it. You balance it if it requires to be balanced. That one is well balanced. So it is not a must to put their figures. Before you put their figures, first look at it. If it is not balancing, then put their figures to balance it. Even without figures, you can say when they say balance the following equation, they give you this one. Rate it the way it is. You have balanced it. Don't struggle that, they will say, what have you added there? No. Look at it. Is it balanced? You have balanced it. Okay? Then, when you go to part B, when they are saying how many grams, okay, of water, you say, again, you start with what has been given. 1 mole of copper oxide solid forms 1 mole of water. Okay? 1 mole of copper oxide forms 1 mole of water. We said once you have the number of moles, then you can change them to grams. And we say this one is 64 plus 16 grams of copper oxide solid forms 1 mole of water is what? Water is H2O. That means here it will be 1 times 2 plus oxygen is 16. Then here you say grams of water. What is the next step? You add. You get 8 grams of copper oxide solid. You say forms that is 18 grams of water. In this one, once you have this, we say that you have done the number. Because what is remaining is putting there 1 gram. We have already looked at it. I've already looked at this one. Then you put there 3.2 grams. You follow the same chain. So with that, I don't think I should go to C. Okay. Because C is saying calculate the mass of hydrogen used in the experiment. You just need to say 1 mole of copper oxide reacts with. Here we shall say reacts with. Okay? So here we have been saying forms. Since this one is reacting with this one, we shall say reacts with 1 mole of hydrogen. Then you change moles into grams. You change moles into grams. After changing moles into grams, then you come to a standard figure. Then you put in 1 gram, you put in the grams given, and you get the right answer. Please, next slide we have the exercise. Next slide we have the exercise. On that exercise, please be able to do that exercise. If you have any comment, drop it on our top television page, or you can visit our website www.codehighschool.ac.ug. If you find if the quarantine ends early and you find it so interesting to come and be next to the source, you can come to Code High School. It is found in Seta Bajo. You just reach there, ask for the office of the head teacher. She will direct you to all offices that you need to visit. Then she will take you to class and you'll be able to study. She's called Madam Tushemelirwe Lydia. When you reach there, you ask for her and you'll be able to access all this work. Most topics have been uploaded on our website. Even if you are not a student from Code High School, you can be able to view these topics. Go there, create an account, log in, look at the topics that have been uploaded, be able to access the work. And I've been your teacher today of chemistry, Saul Chamanya. We are still handling more concept. Let us meet tomorrow, same time, 7 to 8 a.m. Have a blessed day.